Alright, welcome back to our video series on the volume of prisms. So here's another example of choosing appropriate formulas for calculating the volume of a prism. We saw this triangular prism earlier on in the first video. So just recall that volume is base area multiplied by the depth of the figure. And for this one, recall that the base in this case is the triangular shape that we have here. So base area would be base times height divided by 2. So it follows that the volume would be determined by first calculating the area of the base and then multiplying that by its depth. Okay? So in the next example, or first example, we're going to focus on calculating the volume of one of these prism types. So let's have a look and see. Okay, so in this example, we're going to calculate the volume of a triangular prism. Okay, so you can see the base in yellow is triangular. So we're going to you also use the measurement of 1.2 meters as the depth of the object. Okay, so let's start our calculation. Okay. Let's determine the base area of this figure. Okay, so the base area is going to be none other than that of a triangle. So it's going to be equal to the base times the height divided by 2. Okay. So what we'll do from there is we'll go ahead and we'll fill that in. So the base, recall, is given as 2.5 meters. And then the height is 45 centimeters. So recall that 1 centimeter is 0.01 meters. So then 45 would be 0.45 meters. So we'll enter 0.45 into our formula, and then we're going to have to divide that product, which is what you get when you multiply, by 2. Okay, so let's go ahead and calculate that amount. So we'll bring our calculator into view, and we'll determine 2.5 multiplied by 0.45, that's 1.125. Divide that by 2, and we have 0.5625. So 0.5625. Also recall that in terms of area, the units, if we're to indicate them, would be meters squared. Okay? Lastly, we can go ahead and get the volume, because it's nothing more than multiplying the base area by the depth. So volume is equal to base area, we'll just call that BA, multiplied by the depth. So in this calculation, I'm going to include the units just to emphasize a particular fact. So the area is 0.5625 meters squared, and that's being multiplied by a depth of 1.2 meters. Okay. So what I want to impress is that when you take a squared measurement and you multiply it by what we would call a linear measurement, we end up with a cubed measurement, or we end up producing volume, which is measured in cubic units. So let's determine the product of 0.5625 and 1.2, and we have 0.675. So 0.675 meters cubed is the volume of this prism. Okay? So also take note of the number of decimal places that are here. When you're using multiplication, there's another concept called significant figures. It's usually something that we take care of in science or in like a physics class. In this case, we look at both 1.2 and 2.5 have what we call two significant figures. This measurement has three, so we would include at most two figures in our final answer. But for this particular course, we'll leave the answer as is. Okay, so with that example done, let's move ahead to one more for part 2 of our series. So remember, at any point in time, because you are note-taking and because you should be giving yourself time to think about the problems before they're taught, or to give yourself time to process what has been said during the course of the video, pause and take time to reflect. I strongly encourage you to even go through the package to the best of your own ability, complete the examples prior to watching the video back to check your answers. So in this example, we have a cylindrical container, and it's to be planted with flowers. So you can see my particular cylinder is home to what looks like some kind of a palm tree. The container is going to be 2 feet high, and it has to hold 1.5 cubic meters of soil. What is the minimum diameter to the nearest centimeter? So recall that the diameter of a cylinder is a line segment, specifically called a chord in a circle, and it's the longest line segment, and it happens to go through the center of the circle. So if you pause the video long enough to give this some thought, there's a few things that should come to mind. Here are some considerations. We might need to consider how feet and meters are related. Okay, and you're going to see this particular conversion fact in assignment 3, where you have to practice converting from one unit of measure to another. You should consider that volume of a cylinder, okay, is pi times the radius squared multiplied by the height, or the depth of the cylinder. Give consideration to what you're trying to find. You want the diameter. So how is the diameter related to the variables in this formula? Okay, here's the big question. Remember, during our gazebo task in the first unit on trigonometry, the concept of diameter and radius were discussed, and I believe we came up with the fact that the diameter is twice the radius. So that's going to be important for us. Some other things that you might want to consider is, if I'm working with a formula, what am I going to be comfortable with? Am I going to substitute, then rearrange to solve? Or am I going to rearrange the formula, then substitute and solve? So a lot of different considerations. But I think most importantly, the one thing that we need to get by the end of it all is that the diameter is going to be double the radius, which means that you need the radius, and it's not provided, right? It's not provided in the diagram. So that should be our focus. So when we come back to part 3, we're going to enter into a calculation that involves the formula for volume of a cylinder, as well as the relationship between the diameter and the radius.